I'm now starting the homework questions from section 8.3, and for problem number 1, I need to find the exact value of each expression if theta equals to 30 degrees. Now, since theta equals to 30 degrees, we're kind of focusing our attention on the 30, 60, 90 triangle. So this is one of the special triangles that you do need to memorize for pre-calculus 10. And I do have the triangles kind of drawn out for each problem here, so let's go ahead and evaluate each problem now. So we know that sine theta here, we know that theta here is going to be 30 degrees. So this question is asking what is the exact value of sine 30 degrees. So in order to do this without a calculator, you have to refer back to this special triangle here. And here's 30 degrees. And sine is really your opposite over your hypotenuse. So what is the opposite on this special triangle? Well, opposite from 30 degrees is 1, so it's going to be 1 divided by, and the hypotenuse here is 2. So my answer is 1/2. All right, moving on to letter B now. So I have cos theta, and remember, theta is 30 degrees. So this question is asking, what is the exact value of cos 30 degrees? Well, here's 30 degrees right here, and for cos theta, that ratio is your adjacent over your hypotenuse. All right, so what is your adjacent? Your adjacent is root 3. So it's going to be root 3 divided by the hypotenuse, and the hypotenuse here is 2. So root 3 divided by 2. So for all the questions on this very first page from section 8.3, you need to look at the 30, 60, 90 triangle and read the numbers on the sides. Okay, for letter C, I have tan theta. So this question is asking what is the value of tan 30 degrees? All right, remember tan, the ratio for tan is using the opposite and the adjacent, right? So here's my 30 degrees. The opposite is 1. So 1 divided by the adjacent, which is root 3. So 1 divided by root 3 for letter C. Okay, let's move on to letter D here. So now I have sine of 2 theta. So sine of 2 theta, and what was theta again? Theta was 30 degrees. So this is really asking what is sine of 60 degrees. All right, so we're no longer looking for 30 degrees, we're looking for 60 degrees because of that 2 here, right? So 2 times 30 is 60. Now find your 60, and remember, sine is opposite over hypotenuse, so the opposite is root 3, and the hypotenuse is 2. So root 3 divided by 2 is your answer for letter D. Let's move on to letter E here. So because of this 2 here, I'm no longer looking for cos of 30 degrees, but I'm looking for cos of 60 degrees, right? 2 times 30 is 60. Now I need my adjacent and my hypotenuse for cosine. So find my 60 degrees. What's my adjacent? My adjacent is 1. So 1 divided by the hypotenuse, and the hypotenuse is 2. So 1/2 for cos 2 theta there. All right, next one is tan 2 theta. So just like the other 2 here, we're not looking for tan 30 degrees, but we're looking for tan of 2 times 30, and 2 times 30 is 60 degrees, right? So tan is 60 degrees. Now tan is your opposite over your adjacent. So where's your opposite? Your opposite is root 3, and your adjacent is going to be 1. So root 3 divided by 1 is root 3. Okay, let's move on to letter G now. For letter G, I have this sine squared theta. So this sine squared theta, what it really means is you're doing this, sine squared of 30 degrees, and this is the same thing as sine of 30 degrees all to the power of 2. So that 2 right there in the middle is really raising everything to the power of 2. So what is sine 30 degrees? Now remember, sine, the ratio for sine is opposite over hypotenuse. So here's your 30 degrees. Your opposite is 1. So this is going to be 1 divided by the hypotenuse, and the hypotenuse is 2. So 1 over 2, all raised to the power 2. And that's the same thing as 1/2 times 1/2, which is 1 over 4. So 1/4 is your final answer there. All right, for letter H, I got cos squared theta. So this is the same thing as cos of 30 degrees, all to the power of 2. So let's go ahead and find the 30 degrees. And cosine is adjacent over hypotenuse, right? So I got to find my adjacent and my hypotenuse, right? So the adjacent is root 3, and the hypotenuse is 2. So this is going to be root 3 divided by 2, all to the power 2, which is the same thing as root 3 divided by 2 times root 3 divided by 2. Root 3 times root 3 is going to be 3, and 2 times 2 is going to be 4. So my final answer is 3 divided by 4. All right, now I have tan squared theta here. So tan squared theta, so this is the same thing as tan of 30 degrees, all to the power of 2. So there's the 30 degrees. Now remember tan, the ratio for tan is going to be opposite over the adjacent. So what's the opposite here? The opposite from 30 is the 1. So it's 1 divided by the adjacent, and the adjacent is root 3. So 1 over root 3, and then we're raising that all to the power of 2, which is going to be 1 over root 3 times 1 over root 3 equals 2. Well, 1 times 1 is 1, and root 3 times root 3 is 3. So 1 over 3 is your final answer there. Okay, let's move on to letter J now. So J, we have some other things going on here. Sine squared of 2 theta. Now, if I do 2 times theta, that's going to be 60, right? 2 times 30 is 60, so I need to evaluate sine of 60 degrees all to the power of 2. All right, so that's the problem that we need to evaluate. Now, where's the 60 degrees? It's right there, and sine is opposite over hypotenuse, so the opposite is root 3, and the hypotenuse is 2. So this is going to be root 3 divided by 2, all to the power of 2. So that's going to be root 3 divided by 2 times root 3 divided by 2. And root 3 times root 3 is 3, and 2 times 2 is 4. So my final answer is 3 over 4. All right, so once you do a few of these, you start getting used to the kind of problems and looking at the triangle here for the 30, 60, 90 triangle here. All right, so cos squared of 2 theta. So 2 theta here means 2 times 30, which means 60 degrees. So I need to evaluate cos of 60 degrees, and all that is being raised to the power of 2. So here's my 60 degrees right there. Cosine has the ratio of adjacent over hypotenuse, right? So the adjacent is 1, and the hypotenuse is 2. So this would be 1 over 2, and this would be all raised to the power of 2 there. And 1 over 2 times 1 over 2 is 1 over 4, right? So 1 times 1 is 1, and 2 times 2 is 4. All right, let's keep on moving along here. Next one, I have tan squared of 2 theta. So that's the same thing as tan of 60 degrees, all raised to the power of 2. All right, so where's the 60 degrees? It's right there. The opposite is root 3, and the adjacent is 1. So this is going to be root 3 over 1, all to the power of 2. And if you expand this, this is the same thing as root 3 times root 3, and the same number times its the same radical times the same radical is just the inside number, which is just 3 there. So 3 is my final answer for L. Okay, let's move on to M here. Now a few more operations to do here. Sine squared theta divided by 2. Okay, so remember theta was 30 degrees, so this is sine of 30 degrees, all to the power of 2 divided by 2. All right, let's go ahead and evaluate what sine 30 is, right? So 30 degrees is over here. Sine 30 is your opposite, which is 1, divided by your hypotenuse, which is a half. So this will be 1/2, all to the power of 2 divided by that 2. So now we're just giving a few more numbers to crunch out, and let's go ahead and do that here. So 1/2 times 1/2 is 1 over 4 divided by 2. And when we're dividing a fraction by a number, those two numbers multiply, so that's going to be 1 over 8. So 1 over 8 is my final answer there. So remember, I mean, if you forgot how to do that, that's the same thing as 1 over 4 divided by 2, which is the same thing as 1 over 4 times 1/2, and that gives you the 1 over 8. All right, so some number operations for that particular problem. And I suspect n is going to be very similar. So I have cos squared theta divided by 2. And okay, so this is the same thing as cos 30 degrees, all to the power 2 divided by 2. All right, so where's the 30 degrees? It's right there. And cos theta is your adjacent over your hypotenuse. So my adjacent is root 3, and my hypotenuse is 2. Then all that's being divided by 2, and the top is being squared. So now we need to evaluate this weird expression here. So if I do that, that's going to be root 3 divided by 2 times root 3 divided by 2, all divided by 2. So this is kind of testing whether you can simplify fractions. So root 3 times root 3 is 3. 2 times 2 there is 4. And then we're all going to divide this by a 2. Now, just like the previous problem here, if you're paying attention, if you have a fraction divided by a number, all you're really doing is you're multiplying these bottom numbers together, and your final answer will be 3 over 8. So 3 over 8 is my final answer there. Okay, 2 more questions to go for this first part, and then that will be it for part 1.